Hey there, maths fanatics. Get ready to turbocharge your calculus skills because today we're diving into the electrifying world of partial derivatives. Prepare to be amazed as we unravel the mysteries of calculus like never before. So, I'm going to break down this question to you, ladies and gentlemen, to make it as easy as possible. So, obviously, here we're dealing with second order partial derivatives, right? Perfect. So let's just quickly break down this and make it simple. It might look hard, but it's a very simple analogy. I'll show you now. So here I'm going to rewrite this as this, and then f, and then there. You see it? So basically, I broke this squared to this guy and that guy there. Alright, and then we're going to do the same with the second one. And then we have this, and then we have that. Right, so you just broke this, you broke this into that and that. Alright, so ladies and gentlemen, this notation, you might be tempted, you might be tempted to say that, okay, I need to differentiate with respect to x first, then with respect to y. But that is not the case. You see, after I have broken it down here, you can see that, okay, here basically we're finding the derivative of this derivative, right? We're finding the derivative of this derivative. So which means we need to derive with respect to y first, then with respect to x, because we're treating this as our function. All right. Also here, we're treating this as our function. So we're going to derive with respect to x first, then with respect to y. I'm sure that makes sense. So I'm sure we can all agree now that this can be rewritten in this form. This can be rewritten in this form. We can rewrite this as equals to f. Remember, we're going to derive this first. So we're going to do with respect to y, then with respect to x. You see? And then plus f. Here we're going to do with respect to x first and then with respect to y. So we have x, y. Right. And then the exciting thing here is, according to Clairaut's theorem, the derivative of x with respect to y and then the derivative of y with respect to x is going to be exactly the same. So this part will be exactly the same as that guy there. So we can conclude that it does not matter which order you are going to start with. You can start with x first, then come with y. Or you can start with y first, then come with x. The answers are going to be exactly the same according to Clairaut's theorem. So which means here I can just say 2 multiplied by xy. Like that. Do you see? Sure. Because I just said this guy is the same as that guy. Awesome. So now we can differentiate. So I'm going to firstly differentiate with respect to x and then with respect to y. So let's find partial derivative with respect to x. Remember, with respect to x, it means my variable is this one and that one. So I'm going to do chain rule. I'm going to get the derivative of this first, which is cos x. So I'm going to have cos my angle, which is 2xy. And then I'm going to multiply by the derivative of this, right? But obviously with respect to x. So obviously it's going to be x to the power 1 times 2, which is 2. And then we're going to have x to the power 0. So the x is going to disappear. So we just left with 2y there. All right. And then now I need to derive this. So that gives me plus y. Remember, the y is just a constant in this case. So plus y. Then cos x becomes negative sine x. So I'm going to do this actually. I'm going to say negative sine x there. Perfect. And then That is our derivative with respect to x. Now let's go on and derive this again with respect to y now and see what it gives us. So we're now going to have this, but we're deriving with respect to y now. So with respect to y, since here I have a product of two terms, I'm going to do a product rule. So firstly, I'm going to do the derivative of this multiplied by this, and then add with the derivative of this multiplied by that. All right, let's do that. So according to the product rule, the derivative of this will be negative sine 2xy, and then I need to multiply by the derivative of the inside, which will be 2x. Remember, now we're deriving with respect to y, so it's y to the power 1 times 2, which gives us this, and then y to the power 0. It's gone. All right, but we still need to multiply this by the second function, so the second function is 2y. All right, and then we need to add the first function, which is cos 2xy, multiplied by the derivative of the second function, which is 2y. So the derivative of 2y is 2. So I'll have times 2 here. And then now we need to derive this part here. So remember, we're deriving with respect to y. So I have negative 1 to the power 1. So basically negative 1 times 1, which is just still negative 1. But the y becomes y to the power 0. So it's gone. So I have negative 1 sine x. Okay. So I have negative 1 sine x. Remember, we cannot differentiate the sine x. It's a constant in this case. Then now let's just simplify things up. So here I'm going to have negative 4xy sine 2xy plus 2 cos 2xy, and then it's going to be minus sine x. All right, perfect. And that is the derivative, ladies and gentlemen. But according to this, our answer is going to be 2 multiplied by, remember now we can substitute, no? Our x value was 0. If you check, our x value here is 0, and then our y value is 2. So where I see x, I'm going to put 0. Where I see y, I'm going to put 2. Okay, so let's do that. So this is too big. Let me just reduce. So we have 2 f, that is going to be 2 in bracket minus 4. Remember, the x value is 0, the y value is 2. Then we have sine 2 times 0 times 2. And then let's keep on going. We have plus 2 cos 2 times 0 times 2 minus sine 0. All right, now let's see. This part here will be 0. Why? Because we have a 0 here. 0 times anything is 0. All right, so we basically have 2 in bracket. We're gonna have 2 cos 0, because if you check here, this will be 0, right? This part here will be 0. Oh, I forgot to close there. And also sine 0 is 0, so that one is gone. So we just left with this part. Cos 0 is 1, so that's the reason why I'm not taking it away. And if you check here, cos 0 is going to be 1, which means we have basically 2 times 2 times 1, which is equals to 4. Right, and then That's a wrap, ladies and gentlemen. We have conquered partial derivatives like true math superheroes. Keep spreading the love for numbers. And remember, the adventure never ends in the world of mathematics. Stay curious, stay inspired. And until next time, keep crunching those numbers. Aluta continua. Tango.